Okay, we have a severe problem. I know my father's probably said 1,000 times, the tools make the man, we get that. But I don't have autofocus on my camera. And I would love to use my full frame camera, but I've been shooting on film lenses that are 40 years old, and they look amazing, but they don't have autofocus. And am I gonna pay $2,000 for a lens right now on an old, probably 6-7-year-old camera? No. Why? Because we have engineering, so that's what we're gonna do. I want to design a autofocus system out of random parts that I have laying around so that I can have autofocus and use my camera. This is an iPhone, and you know how it is with storage. So this specimen right here is called the Canon 6D. And what's nice about it is it's full frame camera, which means it's gonna be around the same size as one of those 35mm negatives. I just love that. So this lens here, and this is a 1.7 aperture Minolta lens. And I have a little diopter here that lets me put this on, you know, a modern camera, except not modern because this thing is older than Jesus himself. Basically what I think about is just to have a gear system that we could put on the lens here. That way I can kind of control a servo with a gear to turn this around and essentially move it to the right focal length. We've seen this happen many times with cinema cameras. They have, you know, a gear, and then they have this mechanism that can just basically pull focus through one of those remotes. But realistically, I think it's a very simple, cool little engineering problem to solve. Alright, now, I know what you might be thinking. How are you gonna focus on the subject and move a servo as fast as those modern film cameras do with all their unique fancy software? Great question. And I think this is going to be one of the biggest problems running into is you're just pointing an invisible laser through space and you expect it to just, you know, end up on your nose. And are we going to auto-correct it with software? No. We're over-engineering the shit out of this like one of those fancy watches. But maybe you'll learn something, so let's go ahead and just face the fire. But we're going to need more parts. Okay, so I found some random parts here. We got one of them good old breadboards for prototyping. And we have one of these really tiny motors that already has a gear on it, which might be nicer than trying to make our own tiny gear. And then we have one of these. I'm sure you've seen one of these before if you mess with Arduino. So this thing is just a normal servo motor, but we have 3 wires, which is, you know, I don't know, it might be 180 degrees of travel. And I guess we're gonna probably find out the hard way, and if not, it's gonna be a goner. Oh, well, it's a goner. Okay, so thanks, but no thanks. So we're gonna use this. This has a gear on it, which if we just position this in some sort of way, in some sort of holding container thing, which we might mount to the bottom in some kind of frame, and we have a corresponding gear on the lens, we can move the lens with the motor. Okay, that's gonna be phase 1. I think we're just going to have to start out there, and then we'll figure out how to turn the motor later. Okay, so we're going to need to make some dimensions of this thing. Typically what I do is I make the object that I'm going to be designing around first. What I need to do is essentially use the tolerance of this rubber in order to kind of clamp the gear on top of this. Now, I do want to be aware of the rest of the dimensions, so I'll just go ahead and make this entire shape except for the other inner workings of the lens, and we'll make it look pretty. We need to align the teeth around this gear so that they can essentially attach to the smaller gear. All of the teeth that are going to be around here in a very specific shape here, they need to be perfectly aligned so that we're getting a specific gear reduction here on this other wheel. It's going to be moving very fast, I presume. So what I think I might do is essentially have another gear that has all of the matching teeth that we press on to this gear so that we have, you know, a more confirmed kind of size to this other gear. And making this gear bigger is going to be better for the sake of the lens itself. So the lens, the way that this gear will go around, we just have to match the teeth around here. And there's a little bit of math at play. I won't really describe that here, but there is a great video you could check out, and I'll link that. So let's just go ahead and build this gear in Fusion. Decided to go through and just try out 49 teeth. The inner diameter, based off of measuring the lens, is 62 millimeters, which is going to be the inside of the gear, where we're going to basically press this on top of the rubber. And so by adjusting the module size, we can basically get a outer pitch diameter, which is roughly in the scope of what we need. So I think about 75 by measuring is what the outside of the gear is going to look like. We have this involute styled gear with 49 modules. We're basically going to just have to make another gear with a smaller amount of teeth. We just have to go into utilities and add-ons again and start spur gear. Let's make another gear. Okay, we have a second involute spur gear. This, just having 7 teeth, is going to go around, and for every 1 turn of this gear, this will turn 7 times, which means we can kind of deal with the high speed. We have some good torque on this lens, so that way we're not going to be slipping, because we will have a decent amount of resistance. So I like the idea of these gears being a little bit bigger than usual. So what I need to do is adjust the inner size of this gear so that it's going to be a press fit on the motor shaft. So we have this gear, and I went ahead and opened this up in Bamboo. I added a raft, and so we're going to print this gear profile on top of the raft. That way we won't have any bed adhesion issues. So we're just going to go ahead and send this over to the Bamboo. Boom, would you look at that? 3D printing is magic. Perfection. By the looks of it, what we can do is just kind of throw this gear on here. And then we have the same gear for the motor, where we can just pop this on here. And now we have this perfect gear. Amazing. Alright, so we might need to add a little bit of glue in here so that we get the right torque. I had to remove this because the tolerances were a little too tight, but this actually works out. I can just basically run a bead of glue in there and then pop it in, and this thing works perfect. So what I'm thinking now is about designing almost like a hood. So there will be a hood on here, and the hood will give us a mounting point for the motor here. And it seems like maybe this will be a good space, but probably end up doing it right down here on the bottom. And also, for the next part, I designed a water bottle cap a little while ago, and I put together this little PCB. So this is a battery on it. It's got an ESP32. Actually, this is an NRF, which is kind of annoying, but that's okay. Actually, might switch that out. But I have a time of flight sensor that's on here. So this is going to be great to basically get the distance from the subject to the camera, or to the focal length, their focal plane, that we'll adjust for in order to move the motor. So this is kind of annoying that it's like this shape, because I don't want to have this massive device sticking out of the thing. It would be better if it was kind of like this. And so then I realized that I also have one of these prisms. And so this is just a 45 degree or a 90 degree prism. And so if I put this like this, it lets me put the profile of this PCB like this, and then essentially the light will go in and bounce right into the sensor, so we can measure the distance this way, lowering the overall profile. So what I would want to do is make some sort of package where we can kind of, put all these things together into some sort of mounting point that will let us measure the light and move the motor. So I'm just going to go ahead and jump into Fusion and start designing that. One thing to keep in mind here is just that designs change all the time. We abandon certain things, we add other things, and you might notice I came up with a couple ideas for things that I eventually just completely changed. Relentless iteration. When you run into an issue, you find a new solution, you find new parts, and that completely changes the whole design. It's this iterative process that makes great design. And I think that's one of the coolest things about inventing new objects that never existed before. Okay, so this is what I came up with. I needed a way to mount the bottom of the bracket here. That's going to be essentially right where the camera will be sitting. I needed a way to mount that to my tripod because I'd be only using the autofocus on the tripod. Otherwise, I would just focus the camera, no problem. So it has to be on my tripod, but I couldn't find a way around either having a long screw and a second tripod mount, or essentially just not using the tripod. And so I realized I could just make another tripod mount. So that's what this is. So the tripod mount has to go up inside of here in order to clamp on. This is where the screw would be, and you'll see this out a little bit later. And so the only way to support the rest of this mechanism here was with these two areas, and I still need to keep the profile of where the camera would be. And then as for the front, the motor just kind of slides right into this area here. IR sensor, I actually found one that was disconnected. I'm going to just glue in here, and the wires will run right through this track to the back of this little slot here, which is where the ESP32C6 is going to sit. The USB-C port will be accessible through this channel here. Here is the slice. So we got some tree automatic support material. Let's go ahead and send it to the bamboo. Okay, so this is that tripod mount that I mentioned before. And you can see that it has a very similar profile right here. Just like a normal tripod mount. And we just kind of screw this thing in, and boom, we have a really solid mount for this thing, which mounts like this. So everything aligns perfectly, which is a really good sign. The IR sensor will fit basically perfectly in here, just like that. And then the ESP32C6 will mount just like this inside of here. We'll take the wiring from the I2C channel down right to where I would need it, and as well as the power and ground. Okay, so let me Dremel this out. Okay, so I definitely did not already try this, but if I go and I give it power, we don't have enough torque out of this motor. This is 9 volts, and it's not enough. Now the question is, do I give up? Wait. It's kind of, I might be able to give it another bigger gear, and then maybe some more power, but there's no way in hell I'm gonna be able to do this off of 5 volts, especially because the USB-C, when plugged into the Seed Studio ESP32C6, it's just 5 volts is definitely not going to be enough. If anything, I might need to step this up to something bigger. You know what? I mean, maybe we can fry this thing right now. I wonder what Okay, so definitely don't try this shit at home, kids, but we might start smoking, or maybe we'll move it. I really don't care to try to figure out the numbers about this tiny little motor. So we'll just see if it's enough. Well, I think we broke it. 20 volts. Yeah, we broke it. That's probably because it couldn't handle anything more than 12 volts. Yeah, okay, roll the outro. Okay, so it seems like we need a better motor Or we need some better gearing system so that we have enough torque to actually turn the lens. Do we go through and make a better motor for this thing? Do we replace the motor and get a stepper motor? We have another problem that I realized, which is that we can't actually predict how many rotations that this motor is going to make. We'll just be guessing. So we would need either a Hall effect magnet sensor to know when we shouldn't be turning anymore, and basically how many rotations we're going to be at is a complete guess. You might have thought about this from the very beginning, like, oh, that motor is not going to have enough precision to move specifically to a finite distance that we would have read from the time of flight sensor. So the best case scenario for this whole project is to completely ditch that motor entirely and switch to a stepper motor. Now, I think that's out of the scope of part one. Other than that, I think we learned a little bit about torque. We need to have enough gearing, and we need to have the right motor. Moral of the story, kids, hardware is hard, and you never know what you're going to get yourself into. I don't have any stepper motors just laying around, so I will need to get more parts. So as far as the box of random shit that I have, this is as far as we can go in this video. Let's call this prototype 001, to be continued. Fucking torque.